Next, we're going to talk about vertical stretches and shrinks of our function f of x, and that is represented by an a out in front of our original function f of x. In order to determine if it's a stretch or a shrink, we need to look at the value of a and compare it to our inequalities here. The graph is stretching away from the x-axis when a is greater than 1. So it's getting narrower, it's getting further away from the x-axis and going towards the y-axis, stretching towards that y-axis if a is greater than 1. We consider it a shrink towards the x-axis and going away from the y if a is between 0 and 1. And so in that case, on a graph, you're going to see that the graph is widening. So again, less than 1, between 0 and 1 is a shrink, greater than 1 is a stretch. So let's take a look at a couple of examples. So we want to write g of x, the transformed function f of x, when f of x is equal to just our linear parent function x, and we want a vertical stretch by a factor of 5. So let's take a look at that. Our g of x, we have a vertical stretch by 5, so we're just going to say that it's 5 times whatever f of x is. And in this case, f of x is just equal to x, so we can substitute that and say that g of x is equal to 5x. That's our linear parent function stretched by a factor of 5, so it's going to get closer to the y-axis. Now let's take a look at an absolute value function, and this time we want to shrink by a factor of 1/3. Remember, shrinks occur when the value of a is less than 1. All right, so let's take a look. We would have g of x is equal to 1/3 times our f of x function, and we know that our f of x function in this case is absolute value of x. So we can write that g of x is equal to 1/3 times the absolute value of x, remembering that that 1/3 stays outside of the grouping symbols. Vertical changes occur outside.